So, first rule, the multiplication rule. Okay? First rule is the what? The multiplication rule. So, to multiply powers with the same what? The most important condition here is they both have to be the same what? The same base. You just what? You just add the exponents. That's all you have to do. So basically, as long as you have the base here and the base here to be the exact same thing. So if it's a decimal, it has to be the exact same decimal. If it's a negative number, it has to be the same negative number. If it's a fraction, it has to be the same exact fraction. Then all you have to do is what? Just do what? Add the two tops. That's all you have to do. Okay? So basically, I'm just going to circle these. In my solutions, I always circle these. And just put a plus sign on here. That tells me I know exactly what I'm going to do next. Okay? Everyone, big mistake that some people do is that they also add the b's. So they go like this, for example, 2b, and then they raise it to the power of m plus m. No, that is wrong. You do not change the base. The base stays as what? That's it. That's the only rule we're going to cover for today. Okay, so the rule for multiplying is that you add the addition, sorry, you add the tops n plus m. Okay, all right. So let's look at each one of the examples and do it exactly using this rule. Okay, so let's look at the first one. All right. Okay, 3 to the power of 2 times 3 to the power of 6. Did I have to write it both ways? No, of course not. I am just showing you what multiple ways of what? Of showing multiplication. By the way, there's one more way to show multiplication. What is it? Some people like to use the multiplication sign. Some people like to use the brackets. There is only one more way, Shadi. The dot. Make sure that the dot is what? Not a decimal dot, but a thick dot a little bit above. So do not do it this way. You cannot do 3, 2. Do not put the dot here. No, the dot has to be above, like this. Okay, and it has to be kind of thick than a decimal point. Okay. Oh, sorry. Whoa, I made a mistake. My bad. Okay, what's the base for both of these numbers? 3. So you just put a 3. And then what do you do with these two? You add them up. Nice. So you add them up. So you do 2 plus 6, which is 3 to the power of. Okay. Okay, everyone, just so you know, what do you do after this step? If I asked you to evaluate the number, evaluate, that means what? Find the value, which means you cannot leave it like that. You have got to give me what? One single number for the final answer. If I just told you what, do the exponent rules and leave it as an exponent, then you are more than welcome to leave it like that. If you do it any more one step, you're not going to get any marks taken off, but you don't need to. Okay? What does the question say? If the final answer is a number, evaluate it. Okay? So let's evaluate. So I'm just going to pull this up here. All right. 3 to the power of 8. There you go. 6,561. 6,561. Done. That's it. Nothing magic to it. You just add and then you just plug it in. Okay, let's look at the next one. Oh, my bad. Yes, go ahead. I said that? Where? Oh, okay. Sorry, my bad, everyone. Okay, I think I forgot to make this clear. If the number ends up being a fraction, keep it a what? Keep it. Do not make it a what? Do not make it a decimal. Thank you. Yes, sorry. But if the final answer just becomes a number, can you just leave it as a single number? Yeah. I mean, technically, can you make this a fraction? Yeah. You can put it above what? Yeah, but there is no need. But if it ends up being a fraction, keep it a fraction. Okay? All right. Can someone tell me how the second one is different slightly than the first one? Hamza. There's a negative what? There's a negative power or exponent. But technically, is it still the same base with both of them multiplied? So do I still follow the same rule? 100%. Okay, so again, I'm just going to write it 6 to the 5 dot 6 to the minus 3. What's going to happen to these two? Add them up. Okay, so 6, 5 plus. Now, math teachers hate it when you don't what? When you don't put a negative number in what? In brackets. Okay, I'm okay with that if you do this. I don't mind, but I can guarantee you no other math teacher is gonna like it. So you know what? Let's just go with the flow and do this. What's 5 plus minus 3? It's practically 5 minus 3, which is what? 2. So 6 to the 2. What would that be? 6 times 6. 30. Uh, 36. How is my third one different? What's negative though? Is it the exponent or the base? The base. Okay. Remember everyone, when my exponent is negative, I don't have to put it in brackets unless I'm doing something with it. But if it's by itself, you can just leave it like that. But if your base is negative, you have to put it in what? In brackets. Okay. Again, is the base the same twice? Yes, it is. So it's still the same rule. Again, the rule applies no matter how the base looks like. So obviously here it will be negative 4. And I'm going to surround these two and put a plus. So negative 3 plus 7. What's negative 3 plus 7? Or basically 7 with minus 3. Remember, it's like losing $3 and then gaining 7 back. It's what? It's 4. Okay, so it's negative 4 to the power of. Okay, just write that and pencils down. Let me ask you a question. What do you get when you multiply a negative number by itself twice? How about 4 times? How about 6 times? 8, 10, 12, 14, and so on. What if you multiply the negative number by itself 3 times, 5 times, 7? So what's the rule here? Huh, Kaylin, go. Wins. Yeah. So how does that translate to, how does this number affect my final answer? How does this number affect my final answer? Can someone say it? How does this number right here affect the sign of my final answer? I don't know. What do you think? What do you get when you, Shadi, what do you get when you multiply a negative number by itself an even number of times? An even number. 2, 4, 6, 8, 10, 12, 14. You get what? How about if you multiply a negative number by itself an odd number of times? You get what? Why? 3, 5, 7. Why is that? Can someone explain to us quickly why is that? I'll give you a hint. Think of the pairing. Manal, go ahead. Yes, because if you multiply it in even, what does that mean? Each two negatives are going to give you a what? Positive. And because all of them are paired, all of them at the end will come up to be what? Positive. How about if you have an odd number? Pair, 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 pair. By the end, there's got to be one that's not what? That's no. There's got to be a single negative by itself that did not get what? Paired with another negative. Is it making sense? If it's an odd number, there's a negative at the end that's going to screw everything up. But if it's an even number, each two are going to what? Pair up to make you what? Positive, positive, positive. So without, basically, why am I saying that? Because then you don't have to put the whole negative 4 in the what? In the calculator. Look, you do not have now to put this. You don't have to put 4 negative to the power of 4. You don't have to do that. You know it's going to be positive. So you can just say, sorry, you can just say positive. Well, you don't have to say positive, but I'm just going to write positive today. And all you have to put in the machine is just what? 4 to the power of 4. Done. 256. Okay, so always make your work as little as possible. You don't always have to plug in everything in the machine. Okay, next one. More or less the same idea. So it will be negative 5. Let me zoom in. Negative 5. What do we have? Negative 3 plus 6. Okay. Who can tell me what's negative 3 plus 6? Or 6 minus 3? 3. A solid 3. Interesting. I'm multiplying a negative number by itself. How many times? How many times? 3. Is 3 an even number or an odd number? Which means are all the minuses going to be paired up, or is there going to be one of them not paired up? One of them is going to be not paired up. I mean, even look at it. Look, obviously, you never have to do it this way. Negative times a negative times a negative. Those two will clean up, but then this one will not clean up. That's my point. So all I care about is that my final answer is going to be negative. And all I need now is what's 5 times 5 times 5? So 125 with a minus because the minus was already put there. Done. Okay? How is that one different than the other ones we've done so far? What kind of a base do we have now? Our bases now are fractions, but are they still the same base? Yes, they are. Same denominator and same numerator, sorry, and same denominator. So that means we still apply the exact same rule. Okay, let's look at this one. So zoom in. So what do we have? We have a 3 over 4 repeated twice. So that means it's the same base. And what do I do with these two? What do I do with these two? Come on, people. Plus, exactly. So I add them up. What's minus 2 plus 5? 3, or 5 minus 2. Who knows what to do here? By the way, there are two ways to do this now. There's a long way, listen up, and there's a shorter way. What would be the long way? To legit write the fraction how many times? So think about this way. You write 3 times 4, sorry, 3 over 4 times 3 over 4 times 3 over 4. How do we multiply fractions? Do we crisscross or do levels? How do we multiply fractions? We only do what? Which means you multiply all the what? All the tops together. And when do you cross multiply? Only if you have what between fractions? Come on, people. You've done cross multiplying for 40. So when there's an x, but when there's a what between two signs, two fractions? An equal sign. You're trying to cross multiply to solve. Are we trying to solve here for an x or just evaluate a number? We're trying to just evaluate a number. So basically, it's got to be 3 times itself how many times? And 4 times itself how many times? So what can you always do? No need to write the whole thing. You can just write this. Look, this is always my way of showing it. I point to this one as if it attacks it, and I point to this one. So what do you get? 3 to the power of what? Over. There you go. The power attacks each level. What's 3 times 3 times 3? Anyone? 20. Thank you. 27. What's 4 times 4 times 4? 64. Do you think this fraction simplifies? In other words, do you have a number that these two mutually divide together? Okay, always start with this. You know what? Hamza's right. It's a no. Let's start with the smaller number. Which one of those is a smaller number? 27. Can someone tell me what divides 27? Obviously, all numbers divides what? So 1 is useless. What else divides 27? Come on, think small and go big. 3. Do you think 64 divides 3? Does anyone remember the trick to dividing threes? Maybe I mentioned this course. I'm not sure if we mentioned it. Maybe I mentioned it in the first couple of days when we were reviewing the fraction. Who remembers the trick to knowing if a number divides 3? What's up? I did not? Okay. Everyone, add the digits. What's 6 plus 4? Come on. 10. Does 10 divide 3? No, it doesn't. That's it. Everyone, just add the digits. If the addition itself divides 3, it works. If it doesn't, the number wouldn't work. How about 27? What's 2 plus 7? Does 9 divide 3? That's why it works. Okay, what does 27 also divide? It divided 3. Go up. Go up. 9. Do you think 64 divides 9? No, it doesn't. What else does the 27 divide? Nothing. That's it. So that means, is that our final answer? Absolutely. That's it. The reason I went through this exercise with you is that, remember, you're in grade 11 now. So in grade 11 or 12, Even if the question doesn't say what? Simplify your fraction, you still have to what? You still have to simplify it. Otherwise, you do not get full marks, even though your final answer is correct, but it's not as small as it could be. Okay, so don't say that the teacher did not say in the question, simplify. You know you have to regardless of the question. All right, next one. Is it more or less the same thing? Yes, the same fraction base, and then I'm multiplying, so I'm adding. All right, so everyone, let's surround these or box them or circle them and do a plus. Okay, minus 5 over 2, negative 3 plus 7. Okay, what's negative 3 plus 7? 4. 4? Yeah, 4. What did we say that 4 is going to attack? How many things would it attack? How many? It would attack how many levels? It would attack the top level and the bottom level. But what's special about my top level? My top number is what? A negative. So I need to use a what? I need to put it in a bracket. Everyone, do not just say this. I mean, you can point. That's fine. But you can never do this. Please do not do this. That's wrong. You have got to put it in a bracket. Now it's good. Divided by. Do I need to put this one in a bracket? A positive number? Do I need to? Could I? But there's absolutely no need ever. Okay, so let's go back to the trick. What's a negative? Multiplying itself 4 times. Positive, yes. So that means all I need is 5 times 5 times 5 times 5. What's 5 times itself? Only 4 times. 625 indeed. With a plus, you don't need to write the plus. How about 2 times 2 times 2 times 2? 16. Do you think this this fraction simplifies? I don't know. Let's see. What divides 16? Always start with the smaller number. What divides 16 aside from 1? Come on, what's the smallest number after 1 that divides 16? No? Again, okay, you know what? Rauda said 3. Rauda, what's 1 plus 6? 7. Does 7 divide 3? No. So the 16 does not divide 3. That's always one of the best, quickest trick you can do. So what? 4. Do you think this one divides 4? Can an odd number divide an even number? No way. If you divide an odd number of dollars by an even number of people, no way they're going to get what? An exact whole number of dollars. Okay, you're going to get a decimal or a fraction. What else divides 16? 2. 6. Not 6. Not quite. 2. Does 625 divide 2? No. What else divides 16? We just did it. It doesn't divide. All of them divide 1. So 1 is useless. Remember? 1 is useless. All of them except 1. Come on. What's have 8? Again, does 625 divide 8? No. An odd number can never divide an even number. By the way, could an even number divide an odd number? Give me an example. Come on, people. An odd number can divide an even. But could you divide an even number by an odd number? Okay. Rixar, give me an even number. Any even number you want. Make it big. Go ahead. Any even number you want. 63 is odd. I need an even number. 64. Okay, 64 is an interesting example. It only divides even numbers. Give me another even number. No, make it big. Make it big. Come on, people. Give me an even number that's kind of big, like between 1 and 100. 800. 800 is a what? Even number. Guess what? It divides what? It divides 5. 5 is a what? Odd number. So even numbers could divide what? But odd numbers could never divide what? Nice. Again, why am I telling you these things? It saves you time if you're trying to what? To actually guess what numbers work and what numbers don't. Okay? All right. Okay, let's do this one. Same principle. What do you think? 100%. Let's do this. So it's negative 7 over 4. Okay, what do we have here? Negative 8 plus 9. Hey, what's negative 8 plus 9? Or practically 9 minus 8? 1. Okay, technically, what's anything to the power of 1? Everyone, what's anything to the power of 1? Is it 1 or is it the same thing? Yeah, it's like multiplying by 1. It's the same thing. Look, for example, everyone look. 4 to the power of 1. 4. That's it. So really, you don't need to do anything. You can just... Do you need the bracket, though, now? Everyone, for your final answer, do you need to show the bracket? No, because we already cleaned it up. Yes. No, no, I'm going back. I'm going back. Okay. Same thing. Yes, please. You talk about that one? What do you mean split 2? Yeah, yeah. No, no. So we write this once. We write this once, like this. And then what do I do with these two? That's it. Yep. So 9 plus... What's 9 plus minus 4? Nope. It's like gaining $9, but then losing $4. You still have how much? 5 negative or 5 plus? 5 plus, because the 9 is positive and it wins over the minus 4. Nice. Interesting. Attack, attack. Let me squeeze this a little bit. I think I can. Yes. What's negative 2 multiplied by itself 5 times? 5 times. Positive or negative? Negative. Perfect. I just need the negative first. Okay. Now I just need to worry about what? 2 times 2 times 2 times 2 times 2. Who's got this? 32. Yes. How about 5 times 5 times 5 times 5 times 5? 3,125 times 12. Yep. Do you think you can simplify that? I don't know. Let's look at the small number. What's the smaller number? 32. What divides 32? Come on. Start small. 2. Does 2 divide an odd number? No. What else? 4. No, 5 doesn't. I'm talking about this guy. Talk about this. Always talk about the small number. What does it also divide? 4. Not gonna work. 8. Not gonna work. 16. Not gonna work. 32. Not gonna work. Done. That's it. How is this one different than all the other ones we did? We don't have numbers. We have what? We have letters or variables or symbols. But is it still, is it still the same base? Huh. So that means what? Do I still apply the same rule? I do. So what's my base? Just what? Lowercase d. So you just write a d. And on top, you put what? Minus 3 plus 8. What's minus? Yes. Ah. No, go ahead. Which one? Like this one? Yes. Uh-huh. Thank you, everyone. Everyone. No, no, hold on, hold on. Very good observation. Let me show you basically a very quick thing here. Louise is saying that it's showing here that the whole thing is negative. Let me ask you, is it writing it like this? How many people get this on their calculator sometimes? Okay, everyone. This one could be written in one of two different other ways. You can either put the minus where? With the top number, or with the what? With the bottom number, or where? Do you see what I mean? Any place, it would still mean the same thing. And let's prove it. So I am claiming in response to what Louisa said, that this number is equal to this number is equal to what number? Where's the minus now? Okay. How do you prove it? Plug all of them in and see if they all give you the same what? The same exact decimal. Let's do this. Let's plug in the first one. I'm going to plug in this one. What do I divide? By what? 32 divided by 3125 with a negative. That's how my calculator. Okay, let's do the second one. 32 with a negative divided by the positive. Same answer. What's the last one? The last one is technically 32 divided by 3125, and then you make it what? Is it making sense now? Okay, everyone. No, no. Hold on. Hold on. No, no, you're right. But everyone, just so you know, math teachers are always okay with 2 out of these 3. Which 2? This one and this one. What does that mean? No math teacher likes to put the negative where? It's a big, big, big no-no. If you ever have a negative at the bottom, you have a choice. Either bring it what? Up, or bring it where? On the side, okay? But never keep it with the bottom number, okay? I did not make the rules. It's just the way things are, okay? What's up? No, you know what? It's because technically in life you never divide by a what? You never divide by a what? A negative number, but you could divide a negative number on top. That's why. Okay. Let's see. So Louisa, all good? Awesome. All right. Okay. What would this one be? What's negative 3 plus 8? Thank you for saying that, by the way. 5. Hamza, can you do any more with this? Can you evaluate a number? You don't even have a number for the variable, right? What if I told you that d, lowercase d, is equal to 7? Then can you take it one step further? Yes, you can, because then you have to give me 7 to the 5, which is whatever it is. Nice. Okay. Next one. Okay. Everyone, listen up. Pencils down. This one is important for 2 reasons. Number 1, how many things do I have? 2 or 3 things? I have something times something times something. Do you think the rule still applies? Yes, the rule applies if you even have what? 1,000 things multiplying together. As long as they what? Multiply. But there is one thing not showing. What? How many people say this is a 1? How many people say it's a 0 because it doesn't show? Okay. Say again? It's a 1. But my question is, why is it not 0? And why? The question I'm asking is that so many people think when something doesn't show, it's a what? It's a 0. But actually, it could be a what? It could be a 1. Do you know why it's not a 0? That's actually not tomorrow's lesson. Wednesday or Thursday, depends. Uh-huh. Everyone. Anything to 0 is actually what? But anything to 1 is what? No. You're mixing it. Anything to 0 is, but anything to 1 is, no, not 1. No, itself. You just said it 2 minutes ago. It's because you think I should flip my statement, right? I say everything to 0 is 1. So when I say everything to 1, everyone says, oh, it's the other way, 0. No, 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 it's itself. And because I want W to stay itself, what do I put here? So everyone, whenever you do not see a power, put what? Put 1. All right. So what do I do now with these 3 numbers or 3 powers? Add them up. So I get W equals 1. Sorry, I mean 1 plus minus 7 plus 9. How much is that? Well, I always like to do the things that are like each other together. 1 plus 9 is what? 10. 10 minus 7 is 3. Can we do any more with this? Nope. We're done. That's it. Full marks. Okay? 2 to go. What base do I have here? Come on. What base do I have here? A, a fraction. But is a fraction with numbers or a fraction with symbols? But do I still at least start the same way? 100%. Okay. It's still x over y. What if this one was y over x? Can I even do anything? No. It has to be the exact what? The exact same base. If it's not, we can't do anything. What's up? Oh, if this one is flipped, but this one is good, then at least I can operate on these 2. Yes. So Shad is saying, what if 2 of them out of the 3 are the same? Then at least I can fix these 2. Oh, yeah, I can write it, but yeah, I cannot apply the rule. You're right. So here, what do I do here? 3 plus minus 4 plus 6. What is that? 3 plus minus 4 plus 6. Well, 3 plus 6 is 9. Take away 4, that's a 5. What's the only thing I can do now? We did it with fractions. What do I do? Haley, any idea? I don't have numbers, but I do have what? I do have a fraction with a common power on top of both of them. What did I do? Thank you. You attack each one. You see, variables are still numbers. The only difference is that the very final step, we cannot do it, which is evaluating a whole number. So x to the 5, y to the 5. All right. Last one. Do I have 3 fractions multiplying or just 2? Okay, so that's the easy case. All right, so let me just squeeze this. We do have a minus. That's okay, because this is what I'm going to do. Minus a over b, 3 plus 6. What's 3 plus 6? Okay. Can I do still the attack thing? Yes. Can you leave it like that? Yeah, you can. I'm not going to take marks off if you do not what? Kill the bracket. But if you want, again, what do you get when you multiply a minus by itself 9 times? 9 times. Odd number. You still get what? The negative survives because there is no pairing of 2 minuses. So you get a negative. And then all you have to worry about is just what? Just the what? A? No bracket anymore. That's the whole idea. I don't want to see the bracket. Everyone remember, look. This is called like this one. Like this one. Negative 5 to the 4. Do I have brackets anymore? No, I don't. I don't. But at least I have a what? I have a what? A negative. So it could be, or it should be, negative a to the 9. And that's it. That's all we need to know about what the multiplication rule for all kinds of bases.